Welcome. We're going to go over how to calculate a between subjects ANOVA. So we're going to start with the question. Dr. Fleischer wants to see if the PL you study with impacts one's grade on a pop quiz out of 10 points. In order to do this, he randomly assigns 10 people each to 3 PLs. The groups and the scores were Katie had an average of 6, Lashonda had an average of 9, and Avrami had an average of 8. Alright, now let's take a look at and attack the table down here. So by our rules, we know that sums of squared between plus within equals total. So we can fill that with 90. Our degrees of freedom is going to be k minus 1. And we have 3 PLs, so it's going to be 2. We have within, which is going to be how many people total we have, minus the number of groups. So we're going to have 30, because there's 3 groups of 10, minus 3. It's going to be 27. Our total is going to be large N, which is still 30, minus 1, which is going to be 29. Our mean squared always equals to sums of squared divided by degrees of freedom. So it's going to be 50 divided by 2, which will be 25. Next, we're going to have 40 divided by 27. We end up with 1.481848. Then lastly, we're concerned with getting our F obtained value, which is going to be our mean squared divided by R within. We end up with a F ratio of 16.875. Next, we need to look up our F critical value. We do this by going to our F table, going to the degrees of freedom for the denominator within the error. We're going to round down to 26. In order to be more conservative, we're going to do the 0.05 and go to the second column where it says degrees of freedom for numerator. We're going to do number 2 because we have 2 right here. We're going to end up with 3.37. Since our obtained is greater than our critical, we are going to make the assumption and reject the null hypothesis. For our hypotheses, we are going to type them out. Our hypotheses are all the PL students score the same. At least one is different. The levels are Katie, Lashonda, and Avrami. Alright, next we need to calculate which affects our significance, which we only have 1, and we need to calculate a post hoc. So to do this, we have to do our Q times the square root of this W divided by N. Our Q in this case is going to be the number of means, which will give us the column, which is 3, And the degrees of freedom within, which is 27. And so we're going to go back to 24. So we're going to end up with 3.53. And so we're going to do the math. Equals 3.53 times the square root of our mean squared within divided by our sample size for each group, which was 10. So now we have our 1.3587, which is our honest significant difference. We have our means of 6, 8, and 9. Katie, Avrami, Ashanda. So we need to do the differences. Katie compared to Avrami is difference of 2. Katie compared to Lashanda is a difference of 3. And Avrami from Lashanda is 1. We take this HSD and compare it to these values right here. By doing that, we see that these two absolute values are higher. So therefore, these are significantly different. So the Katie from the Avrami minus A, sorry, A minus K, L minus K, and L minus A. Last up, we need to calculate sums of squared between over sums of squared total to get our effect size, which it is necessary because we found significance. So that's going to be 50 divided by 90. We end up with 0.55 or 55%. 0.5%, and that is our effect size. Congratulations, you've just calculated a between subjects ANOVA. Remember, a between subjects ANOVA is used when everybody belongs to only one group.